I am Karthik from ITA section and my roll number is 1230. And today on concept video, my topic is about mean of Poisson distribution. So let us discuss about mean of Poisson distribution in further slides briefly. So let us go into the slides and know about the mean of Poisson distribution. Before going into our topic, let us know what is Poisson distribution. In statistics, a Poisson distribution is a probability distribution that can be used to show how many times an event is likely to occur within a specified period of time. In other words, it is a count distribution. Poisson distributions are often used to understand independent events that occur at a constant rate within a given interval of time. It is named after French mathematician Simon Dan's poisson. So, in this slide, the we see that in statistics, a Poisson distribution is a probability, the probability distribution that can be used to show how many times an event is likely to occur within a specified period of time. That is, an event occurring in a specified event of time and period of time, and it is a count distribution also we call it, and it was named after French mathematician Simon Dennis Poisson. So this is about Poisson distribution. The Poisson distribution is a discrete function, meaning that the variable can only take specific values in a potential infinite list. But differently, the variable cannot take all values in any continuous range. For the Poisson distribution, a discrete distribution, the variable can only take values 0, 1, 2, 3, and etc. with no fractions or decimals. So, Poisson distribution is a discrete function, means that can only take a specific values in a list, and the variable cannot take all the values in a continuous range, and the Poisson distribution, the variable can only take the values like 0, 1, 2, 3, and it cannot take the numbers or variables, the values should not contain the fractions or decimals. A Poisson distribution can be used to measure how many times an event is likely to occur within X period of time, named after mathematician Simon Dynas Poisson. Poisson distributions, therefore, are used when the factor of interest is a discrete count variable. Many economic and financial data appear as a count variables, such as how many times a person becomes unemployed in a given year, thus lending itself to analyze with a Poisson distribution. So, as we know before, a Poisson distribution can be used to measure how many times an event is likely to occur within a X period of time. And we already know it. Simon Dennis Poisson is named after the mathematician, and Poisson distributions are used when the factor of interest is a discrete count variable, and uh, many economic and financial data appear as a count variables, such as how many times a person becomes unemployed in a given year. Thus, the lending itself to analysis with a Poisson distribution. So, we can take it as an example here in this case, and let us see for the slides. Let us understand Poisson distribution. Understanding Poisson distribution. A Poisson distribution can be used to estimate how likely it is that something will happen X number of times. Let us take an example here. For example, if the average number of people who rent movies on a Friday night at a single video store location is 400, and Poisson distribution can answer such questions as what is the probability that more than 600 people will rent movies. In this example, if we take an average number of people who rent movies on a Friday night, at a single video store location is 400, we are assuming. So in Poisson distribution can answer such questions as what is the probability that more than 600 people will rent movies. Therefore, the application of the Poisson distribution enables managers to introduce optimal scheduling systems that would not work with, and say, a normal distribution. So, therefore, we can say that the application of Poisson distributions enables managers to introduce optimal scheduling systems that would not work with, and say, a normal distribution. So let us hear some more. One of the most famous historical practical uses of Poisson distribution was estimating the annual number of Persian cavalry soldiers used due to horse kicks. Other modern examples including estimating number of car crashes in a city of a given size, and in psychology, uh, in physiology, sorry, this distribution is often used to calculate the probabilistic frequencies of different types of neurotransmitter secretions. Or if a video store averages 400 customers every Friday night, what is the probability that 600 customers will come in any given Friday night? As we seen this example in before slide. So these are some examples. Let us look at them again. Here they say that practical uses of Poisson distribution was estimating the annual number of Persian cavalry soldiers killed due to the horse kicks. Other modern examples, if we take estimating number of car crashes in a given size, and in physiology, means in physics, that this distribution is often used to calculate the probabilistic frequencies of different types of neurotransmitter secretions. So this is about the Poisson distribution. Let us look some more information. So coming to the Poisson distribution formula, the formula for the Poisson distribution, uh, the Poisson distribution formula is f of x equal to lambda power x by x factorial into e power minus lambda. This is the actual formula of Poisson distribution, and e here in the formula, e is the Euler's numbers. We take the e values 2.718 something, and x is the number of occurrences, and x factorial is the factorial of x, and lambda in the formula is equal to the expected value of x when it is equal to the variance. So this is about the formula of Poisson distribution. Let us see once more. F of x equal to lambda x by x factorial into e power minus lambda. As we know, e is Euler's numbers and x is the number of occurrences, and uh, x factorial is the factorial of x, and lambda is the expected value of x when it is equal to the variance. This is about the formula of Poisson distribution. So uh, let us see another example. uh, P of x equal to e power minus lambda x into lambda x by x factorial, in if x equal to 0, 1, 2, 3, and so on, and 0 otherwise. Here n is the number of finite trials, and x is the number of successes, p is the probability of success, lambda equal to np, that is finite and positive value, and mu equal to mean equal to lambda equal to np, and uh, sigma square equal to variance, that is lambda equal to np, and sigma equal to standard deviation root lambda equal to root np. So this is the formula actually, and thank you. This is about the mean of Poisson distribution. Thank you.